Assalamu alaikum wa rahmatullah. Good day everyone and welcome to my YouTube channel where I solve physics problems and explain physics. This is the third video about capacitors, and in this very one we will explain series arrangement of capacitors. Capacitors are arranged in two ways, in series and in parallel, okay? But today we will only consider the series arrangement of capacitors. Now here is an important thing to take note of. When capacitors are arranged in series, okay, in series, they store equal charges. Whenever they are arranged in series, they will store equal charges. Meaning if you have 5, 6, 7, whatever number of capacitors with different values of capacitances, maybe one is 50 microfarad, the other one 20 microfarad, provided they are connected in series, they will store equal amount of charges. If one of them stores a charge of 30 microcoulomb, all of them will store this 30 microcoulomb, provided they are arranged in series. But the PD across them are different, meaning they have different voltages across them. Okay, how do we arrange capacitors in series? This is simple. I'm going to use 3 capacitors as an example. Remember the circuit symbol for capacitors. Uh, uh, this is a capacitor. Please make sure that the lines are of equal length. Okay. Then this one has a capacitance value of C1. Okay, series connection is end-to-end connection, you see. And then I have the third one, the second one, with capacitance value C2, and then I have the third one with capacitance value C3. Okay, let's say they are now connected to a battery source. If they are connected to a battery source, and here is the voltage of the battery. Now remember what we said, when capacitors are arranged in series, this is series arrangement, end to end connection, okay, in a line, in a row, okay. Then what happens, they store equal charges. This means the quantity of charge stored here is Q, the quantity of charge stored here is Q, the quantity of charge stored here is Q. We don't have to put 1, 2, 3 because they are equal, but the potential difference across them are different. So this means the voltage across this should be V1, okay, and the voltage across the second one, the second capacitor, is also V2. The voltage across the third one is V3. You see that? Same charges but different PD. Now, how do we get the total capacitance? So one may say, okay, since they are arranged in series, we just say, okay, the total capacitance will be just C1 plus C2 plus C3, but that is grossly inaccurate. Now, how do we get that? We go back to that formula that we know, okay, but first let's write the relationship between V and this PD here, the voltage of the battery, is shared among the capacitors, okay, in an algebraic manner. So we will say V is equal to V1 plus V2 plus V3, and we call this equation 1. Okay, now we are going to use our formula which says C is equal to Q upon V, the one for general, the general formula for calculating capacitance of a capacitor, any given capacitor. Okay, this formula can be applied to the individual capacitors. If you apply this formula to this one, you will see that it says C1 is equal to, because the capacitance of the capacitance of this one is C1 and its charge is Q and its PD is V1. If you do that for the second capacitor, you will say C2 is equal to its charge is Q divided by its PD is V2. For the third one too, you say C3 is equal to its charge Q divided by the PD across it V3. So it means from here I can make V the subject of the formula in each one of these. um, let's say this means that I can say C1 is equal to Q upon V1. C2 is equal to Q upon V2. Okay, and C3 is equal to Q upon V3. Now what we have here is V. So for this one we will make V the subject of the formula. Remember, you only have to interchange this. So your V is equal to Q upon Q upon C, of course. So instead of the V that you have in equation 1, you can write the right hand side here Q over C, and this one V1 will become Q over C1, because from here C1 is equal to Q over V1. Make V1 the subject of the formula and your V1 is equal to Q over C1, and then V2 Q over C2, V3 Q over C3. So this implies that my equation 1 becomes, instead of V I write Q over C, instead of V1 I write Q over C1. So I have Q over C1 plus, instead of V2 I write Q over C2, instead of V3 I write Q over C3. Now I can factorize the Q here. So here the left hand side I have Q over C, and then the right hand side, if I remove the Q, I have 1 upon C1, plus I remove this Q, I have 1 upon C2, plus I remove this Q, I have 1 upon C3, close bracket Q. Then if I divide both sides by Q, I divide this side by Q, I divide this side by Q, then the Q here will cancel the Q here and you have 1. The Q here cancel Q here. So this means 1 over C is equal to all that I have there. So it means that in the end I have 1 over C is equal to 1 over C1 plus 1 over C2 plus 1 over C3. This means whenever I have capacitors arranged in series, capacitors in series, the total, this one we call it total, whether you call it total capacitance or you call it equivalent capacitance, okay, or you call it effective, it has different names: total capacitance or equivalent capacitance or effective capacitance. Of all, the combination is given by 1 upon C1 plus 1 upon C2 plus 1 upon C3. Let's see problems related to that one. Okay, here is problem solving on series arrangement of capacitors. Problem 1 says 3 capacitors of capacitances 3 microfarad, 4 microfarad, and 5 microfarad are connected in series. Okay, let's see that. Okay, I would like to draw. Okay, whenever there is a problem related to a circuit diagram, I prefer drawing it. Then the first capacitor has a value of has capacitance of 3 microfarad. The second one has 4 microfarad. They are all connected in series. Look at it, very important. Then the third one has a value 5 microfarad. Okay, they are connected in series. What is the effective? What will calculate the total, or you call it effective or equivalent? I put all the three because they mean one and the same thing. In some books they use total, in some books they use effective, in others they use equivalent. It means one and the same thing. Get the total capacitance of the combination. So now, since they are connected in parallel, the equation we've just derived told us that the total capacitance is the reciprocal of the total capacitance is the sum of the reciprocal of the individual capacitors. So we will now say 1 upon C is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3. Now this is equal to, okay, good. This is equal to 1 upon, we take this 3 plus 1 upon 4 plus 1 upon 5. Okay, take note of this. When you are finding the total capacitance, do not change this one. Do not use times 10 to the power minus 6 here, okay? You can ignore that completely. Now, the next is math. What is the LCM of this? Okay, 3, 4 and 5. Well, you can just say, okay, multiply 3, 4 and 5. Bring your calculator, just multiply them. 3 times 4 times 5, and this will give you 60. So you put 60 here. Next, take 60 divided by 3, multiply the answer by 1. 60 divided by 3, this will give you 20. 20 times 1, 20, plus 60 divided by 4, this should give you 15. 15 times 1, 15, plus 60 divided by 5, this should give you 12. 12 times 1, 12. Okay, next you add the numerator 20. Look at it here, 20 plus 15 plus 12, and this will give you 47. So this is equal to 47 divided by 60. But this is not your answer, because here you did not say C is equal to, is reciprocal of C. So to get the answer, you take the reciprocal of both sides and say, therefore your C is the reciprocal of this 60 upon 47 in microfarad. If you like, you can get that in decimal. So 60 divided by 47, this will give you in decimal 1.28 approximately. 1.28 microfarad. Okay, there is another way of solving this one. If you have 1 over C is equal to 1 over 3 plus 1 over what is it, 1 upon 4 plus 1 upon 5, you may also wish to say, okay, this means 3 reciprocal plus 4 reciprocal plus 5 reciprocal. So you bring your calculator and press the 3. Look at the reciprocal here. The reciprocal is here, 3 reciprocal. Okay, you get 0.33. This will be 0.33. Do the same for this 4. Look at it here, 4 reciprocal. This is the reciprocal, and then you have 1 over 4. This means 0.25. 2 decimal places. Okay, okay, plus this one will give you 0.2. Now add this together and see what your result will be. You have 0.33 plus 0.25 plus 0.2, and this will give you okay, in decimal you have 0.78. 0.78. But remember, this is not your answer, because you have 1 over C here. To get the answer, you now say C is equal to reciprocal of this, and reciprocal of this is 1 over 0.78, and this is equal to okay, you press the 0.78 and press reciprocal again. So this will give you this, and in decimal again you can see 1.28. So approximately 1.28. Now we take problem 2. Problem 2 says two capacitors 10 microfarad and 20 microfarad connected in series are connected to a 30-volt DC source. Okay, calculate the equivalent capacitance, the charge on each capacitor, the PD across each capacitor. Okay, let us see the diagram first. Okay, I like this diagram so much. I have a capacitor. You are given a capacitor. This is 10 microfarad. Remember, they are in series, so we joined them end to end. And then you have the second one here, and it is 20 microfarad. This is series arrangement. They are connected to 30-volt DC source. So you have, this is a battery. You look, if you look at this one, the line one is smaller than the other. This is negative terminal, this is positive terminal, but for capacitors the length of the lines are equal. Okay, this has voltage 30 V, so you can call this one your C1 and this one your C2. Okay, first you need to get the total capacitance. So how do we get this total capacitance? We have only two, so we say 1 upon C is equal to 1 upon C1 plus 1 upon C2. Now this is equal to 1 upon our C1 10 plus 1 upon our C2 20. Now this is equal to the LCM of 10 and 20 is 20. Then you'd say 20 divided by 10, 1 times 1, 1, plus 20 divided by 21, 1 times 1, 20 divided by 10, 2, 2 times 1, 2, I'm sorry. Then plus 20 divided by 21, 1 times 1, 1. So this is equal to 3 upon 20. Again, this is not your result because you say 1 upon C, so you have to turn it upside down, take the reciprocal and say therefore your C is equal to 20 upon 3, and now you can write your microfarad. With this you have solved A. Now that you have solved A, they said get the charge on each capacitor. If they are arranged in series, remember what we said. We say each one will store equal amount of charge, Q, Q, Q. How do we get this charge? This charge is related to the PD and total capacitance that you've just calculated. You say B, you say C is equal to Q upon V. This V is the total PD, this very one, and this capacitance is the total capacitance, the one you just calculated. Let us call it C sub T. Then if you want to get the charge, you make Q the subject of the formula, and your Q is equal to C sub T V sub T, and this is equal to, how do we get this? How do we get this? C sub T, you calculated that this is 20 divided by 3, but now you have to use the micro, times 10 raised to the power of minus 6 times VT. V sub T is the PD here, total PD, which is 30. Now this is equal to 3 into 30 is 10. 20 times 10, 200. So you have 200. This 10 raised to the power of minus 6 is micro. So you have micro, and charge is measured in coulomb. So you have micro coulomb. Great. Now for C, how do we get C? C says we should get the PD across each capacitor. Okay. Remember the PD across this capacitor is V1. The PD across this capacitor, you can call it V2, and then you can apply this formula to the individual capacitor. This means you can say that for C1, C1 is equal to the charge stored in C1 divided by the PD across C1, which is V1. Okay, so here you are asked to get V1, so make V1 the subject of the formula, just interchange this, and you have V1 is equal to Q upon C1. Okay, this is equal to this Q. You have already calculated it here, and you got 200 microcoulomb. So you have 200 times 10 raised to the power of minus 6, okay, divided by C1. What is C1? C1 is 10 microfarad. So remember, the micro is always 10 raised to the power of minus 6. Clearly, this one cancel this one, and 200 divided by 10, this will be 20, and PD is measured in volts, so you have 20 volt. Next, you can still apply this formula to the second capacitor. This means you can say again, then you say also, comma, C2 is equal to the charge capacitance of the second capacitor. The charge is stored is also Q divided by the PD across it is V2, so divided by V2. Now make V2 the subject of the formula. Your V2 is equal to Q over C2, Q over C2, and this is equal to the charge is equal, so the charge you calculated, you will use it again, 200 times 10 to the power of minus 6 divided by C2, and our C2 is look at our C2 here, 20 microfarad. So we say this is 20 times 10 to the power of minus 6. Again um, again this cancel this. 200 divided by 20 will give you 10, and the unit is in volt. Can you see? If you add 10 volt to 20 volt, it will give you the total PD. You have 30. This means this one has 20 volt across it, and this one has 10 volt, so that 20 plus 20 will give you the total 30. I hope you understand this. Thank you very much for watching. Assalamu alaikum wa rahmatullah.